Hello everyone. Our team name is Hexabytes. We are a total of 6 students, with our team leader being Shravan from 3rd year computer department. I'm Vaidehi from 3rd year computer department, and there is Unnati with me, also from 3rd year computer department. Both of us will present our topic in this video. Our other teammates are Shweta, Amruta, and Prathamesh, all of whom are from 3rd year computer department. Today, most of us have an old laptop, smartphone, or hard drive lying unused at home. Why? Because we are scared. What if someone recovers our bank details, private photos, or business documents? This fear often stops us from recycling. The result is simple. People hoard IT assets, devices pile up in homes and offices, and this adds to e waste, one of the fastest growing environmental problems. In India alone, millions of devices are discarded every year, but most are never recycled properly. Our mission is to change that. We, Team Hexabytes, have built a secure data wiping solution that removes this fear. Once people trust that their data is erased beyond recovery, they will confidently hand over devices for recycling, helping both the environment and the economy. Our project will be designed as a cross platform tool. Unlike most existing solutions that work only on a single operating system, ours will be universal. It will work on Windows, Linux, and Android, and we will also provide a bootable ISO. This means even if a device's operating system is corrupted, we can still securely wipe it. In terms of secure erasure methods, the tool will also support all modern storage types like HDD, SSD, NVMe, eMMC, and UFS. Importantly, it will not just wipe the visible storage space but also hidden areas like the host protected area and device configuration overlay, which often contain sensitive, leftover data. After each wipe, the system will generate tamper-proof certificates of erasure in both PDF and JSON formats. These certificates will include a QR code for quick mobile verification and will be anchored on blockchain, making them immutable and trusted. For example, if a company wants to resell 100 laptops, they can show these certificates as a proof of compliance with international standards. We will also use an AI wipe recommender. For example, a traditional hard drive might need a 3-pass overwrite, but an SSD requires a different method. The AI engine automatically selects the fastest and most secure option for each device. To ensure traceability, each certificate will be linked to the device's unique identifier, such as its serial number, IMEI, or drive ID, so that it cannot be reused or duplicated. The user experience will be simple and intuitive. At the core, we will have a wipe engine developed in Rust or Go. These languages give us high performance and security, while ED25519 cryptography will ensure that all wipe logs and certificates are digitally signed and tamper proof. The front end will be built using modern frameworks like React or Next.js, while the back end runs on Node.js or Go. This will provide a clean, responsive dashboard for both recyclers and individual users accessible from any browser. For device level control, we will integrate proven tools such as NVMe CLI, HDPARM, BLK discard, and ADB through the backend. For devices that can't boot into an operating system, we will also provide a bootable ISO so wiping can be done offline. Once the wipe is complete, a certificate of erasure will be automatically generated in PDF and JSON formats. These certificates will include a QR code for instant verification, and all records are anchored on blockchain platforms like Polygon or Hyperledger, ensuring an immutable audit trail.
Let's dive into the feasibility and viability of this solution. Starting with technical feasibility, this approach is already grounded in existing global standards such as NIST SP 888, ensuring we are following industry best practices. We also have existing tools like HDPRAM and NVMe command line interference, which prove that secure wiping is not only possible but achievable. Moving on to operational feasibility, the one-click interface makes the process easy even for non-technical users. Plus, it works offline through a bootable USB, making it viable option for area with limited internet access. To top it off, we offer audit-ready certificates, which mean enterprises can easily demonstrate compliance during regulatory checks. As for resources feasibility, the beauty of this solution is that it requires only existing hardware. The development effort is moderated because we are combining well established technologies, making it cost effective and efficient. However, like any initiative, there are challenges and risks to consider. There are drive specific queries. Some drives doesn't respond as expected. User adoption could be another hurdle, as many citizens may not be aware of this importance of secure wiping. Low tech environments such as rural villages or offline area present unique challenges as well. And of course, we must also prevent fake certificates from undermining the system credibility. So, how do we overcome these obstacles? First, we will maintain a comprehensive database of known drive queries to troubleshoot any compatibility issue. For drives that doesn't support secure erase, we will use fallback override method to ensure security. To help user in all region, we will offer multilingual voice guide tutorial, making it more accessible to everyone. For trust, we will anchor certificates on the blockchain, providing an immutable record of certificate. Lastly, to drive adoption, we will incorporate gamification, making the process engaging and rewarding for citizens. By addressing these challenges head on, we are not only making this solution feasible but truly sustainable and accessible for all. When we talk about the viability of this approach, we see clear benefit across multiple areas. Economically, it helps reduce the costs associated with hoarding IT assets, supports the resale of devices, and even open up opportunities for monetizing through SaaS. Now let's explore the impact and benefits of this solution. First, user confidence. When people know their data is securely erased, they feel more comfortable recycling their devices, contributing to a safer digital environment. For compliance and regulation, this solution meets both global standards and the Indian Act requirement, ensuring enterprises can easily demonstrate compliance during audits or regulatory checks. In terms of security benefit, it's a game changer. By securing wiping devices, we prevent data breaches, frauds, identify thief, and espionage. This eliminates the risk of sensitive personal or organizational information being leaked. Looking at the environment impact, it helps reduce e-waste and save carbon dioxide emission and conserve valuable landfill space, all key to our sustainable efforts. For an economic standpoint, this solution unlocks 50,000 crores worth ideally IT assets sitting unused. Device can be resold, reused, or contributing to a circular economy. And there are social and educational benefits too. It builds trust among citizens, raises awareness of safe digital disposal, and helps improve cybersecurity habits across the population. Now let's look at the lasting impact of this solution. On the social front, citizens develop trust in recycling process, leading to less hoarding of old devices and more responsible approach to digital waste. Economically, old devices gain resale value, which can help boost the digital economy and create new opportunities in tech sectors. To ensure exabyte is built on solid foundation, our approach is backed by a range of peer-reviewed IEEE research paper. Let me highlight few of them. First, Komanduri and Patel in their 2021 paper published in IEEE Transaction on Dependable and Secure Computing outline the key challenges, future direction in data sanitization for solid state drives. This directly informs how we handle secure wiping in modern storage devices. Then we have Chen Lu Ren, whose work in IEEE transaction on computers dives deep into the reality of secure data deletion in consumer flash devices. This helps us understand the hardware level constraint and how to navigate them effectively.